Welcome to my fourth section of my video series. In this section, I'm going to explore how you can use Keras to generate text. We're going to introduce to you what a recurrent neural network is. This is important to the foundation of generating text. I'll explain to you how to go about collecting some of the right datasets in order to train the right model to be able to generate text. Finally, I will walk you through how to train your Keras model, and then finally, how to test that model out. In this first video, I'm going to give you an introduction to recurrent neural networks. I'm going to explain to you what a recurrent neural network is, and I will then talk to you about generating text with a recurrent neural network and how that works. First though, let's take a step back and explore how to generate text. Let's think about how a neural network would go about predicting the next word in a sentence. Let's take a sentence. I will drive my blank. Now, a deep learning neural network could predict what the next word in this sentence could be. It could be, for example, car, truck, bike, and there'll be probabilities associated with these. Let's say 60% based on car, 5% based on truck, and 35% based on bike. But sometimes, and most importantly, context matters a lot. If this sentence was preceded by the following sentence, I put on my helmet, I will drive my blank, this will dramatically change what the probabilities are. The probabilities for car and truck would decrease, and the probabilities for bike being the next word would dramatically increase. The context here is very important, and as with all written text, context is very important, and that context could be right next to the word, or it could be previously captured in a paragraph before. And this is where recurrent neural networks come in. This is a type of deep learning neural network. They are essentially networks that have loops built into them, which really allow them to contain information about previous inputs and outputs. The output vectors, i.e. the word being predicted, are influenced not only by the immediately preceding word, but also the entire history of inputs that you fed into this recurrent neural network. This allows it to maintain some level of context about what words to predict next. However, a challenge does arise. If we take this example, let's say a paragraph started, I was born in Paris, France, and then there was a whole slew of text, and that resulted in saying I speak fluent something. Now the machine learning algorithm, if it knew about the first sentence, could potentially predict that the next word here is French. But it would have to maintain a lot of history depending on how much was between the starting sentence and the end sentence. The challenge that lies with recurrent neural networks is that this is a lot of information, and as it moves further away from that starting sentence, the context of that becomes less weighted versus others. This is where long short-term memory networks come into play. These are a special type of recurrent neural network that have an additional capability learning long-term dependencies across a sequence of vectors. So this allows recurrent neural networks to have the capability of maintaining context for a lot longer than just simple out-of-the-box recurrent neural networks.